Right, so this project is to try to organize a rather complicated body of literature, which is analytic number theory, which is a big interconnecting network of estimates which are not fully interoperable currently. So I like to categorize these estimates into what I call primary estimates, secondary estimates, and tertiary estimates. So primary estimates are things like zero-free regions for the zeta function. Things like this, and these are obtained often through lots and lots of computation. Just big number crunching calculations. And then there's several papers that take some zero-free regions that are known at the time of the paper and convert them to secondary estimates, things like counting primes in short intervals. Okay, and many other kind of basic building blocks of other things you'd like to do in the subject. And then there are these yet further papers that take the outputs of these papers and then have applications to various number theory problems. Okay, for example, asking which numbers are the sum of 3 primes, that kind of thing. And so there's lots and lots of papers that do this, and lots of papers that do this, but and lots of computational work that gives you estimates, but often there's a mismatch. A paper may use an estimate which was available at the time, but in the 10 years later, there's a new computation coming in, but it's not joined up with this paper, and so we don't know what the updated result is over here because of the updated inputs. So what we're hoping to do is to formalize many of these key papers and abstract them automatically to create this sort of living network of implications, which are all very modular, and so that when you can add or subtract literature, you can say, okay, let's see what's the best result we can get on one of these applications using only results that are available in 1980 or 1990. And maybe there's a paper that people are worried that there's a mistake in it, hasn't been formalized yet, where we just take it out of the system and see how much damage it does to the estimates downstream. So we're able to organize the literature at a level above that of a single paper, which is kind of the largest scale that you can do things right now. I'm hopeful that this project will create lots of valuable lessons on how to connect together different papers and different literature which have slightly different hypotheses, not quite compatible. And the hope really is that AI and formalization can kind of create a connecting glue to glue these things together. So number theory is a good test case because we have a fairly well-defined structure, but there are definitely other areas of mathematics, PDE comes to mind, for instance, where we have a lot of results and tools that where there really are significant differences between the conclusions of one paper and the hypotheses needed of another. They don't really fit together very well. And a lot of work by mathematicians is just to modify, trying to fit square pegs into round holes all over the place. But if this paradigm is successful, I believe it can scale to many other types of fields of mathematics. So one dream I have with when we have these type of infrastructures in place is that you could really crowdsource really large-scale projects which were really hard to organize in the past. So a classic example is the classification of finite simple groups. And basically there are many types of finite simple groups, and this whole task took decades, and we sort of passed it off individual cases to like PhD students in finite group theory, each handling one special case. And sometimes there were bugs in some of the papers, and there was some controversy as to whether the whole thing was complete. But you needed like 1 or 2 experts who understood everything that was going on and who could organize the whole thing. And that was kind of the maximum limit of the size of a mathematical project that could be organized before modern technology. But one could imagine a moonshot on the level of the classification of finite simple groups, that maybe there is some mathematical problem that requires lots and lots of diverse case checking, and but different people can handle different cases, and then some AI or some automated technology can glue it all together and see, and say, we have covered 67% of all the cases right now, and you can see some sort of progress bar over time. I think that would be a really new way to do mathematics that would actually be very engaging to participate in, and much faster time scale than the decades that it took to do classification.